We completed our work doing the Java default binary serialization of drawings and being able to load them back in. Now we'd like to add the functionality for doing XML serialization. We've basically already stubbed out in the code where this goes. We have a save action for doing it and an open action for doing it. Now we just need to fill in that code so that it does something. So how are we going to do this? Well, it turns out this is more effort than the default serialization, because the default serialization, well, is default and it's built into Java. You make things serializable and you do a little bit of work to make sure that things that aren't serializable either don't get serialized or you do some custom serialization for them. That all works great. When we do this with something else that's not the default serialization, we have to put in a bit more work. Now, the way that I typically do this is if I want to have objects be serializable to XML, I add a toXML method to them. So the idea here is that I want to be able to do something like this, equals our drawing.toXML, and then I should be able to save it out to the file that we have. And I can do that by doing xml.xml. Actually, this might, let's call it that. Save with a file name, and that will just be file.getAbsoluteFile. The node is our XML data, and all the rest of these actually have default values, I do believe. I want the string version, get absolute path. And let's see how happy that is. So that potentially works just fine, but the drawing doesn't have a toXML. So we have to go through each of the different elements that we want to be able to save and add a toXML to them. So for example, our drawing def toXML is going to return an xml.node. Technically, we could actually return an xml.elem here. And this is going to be drawing, and it ends with /drawing. And then inside of here, it needs whatever information we have. Well, what's in this? It has the root, and it has vars. So the root is actually going to be fairly simple in that I want to do root.toXML, because all of our drawables are going to need to have their own toXML. So if we pull up drawable, I'm going to put another abstract method in here called toXML that returns an XML node. And then we're going to wind up having to add that to each of our different drawable types. Oop, drawing. There we go. Okay. So this will save off the root. We also need to save off the vars. Okay. Well, I could do this as something like I am going to take each of the vars, and this is actually underscore vars, right? Yes. So I want to run through underscore vars, and I want to map each value to some XML. Okay, and remember, when you call map on a map type, the argument is a tuple. So I'm doing this as t, where underscore 1, the first element, is the key, and underscore 2 is the value. And so I am going to output here an XML of an empty element, a var, that says key equals, and then t dot underscore 1 in curly braces, and value equals, and in curly braces, t dot underscore 2 dot toString, because those are doubles. And remember that all attributes have to be converted to strings before we write them out. Okay, so issues that I have here are my brackets and parentheses. Nope, I am missing a closed parentheses on map. That would cause us some problems. Oh, but it doesn't go there. No. So that's the close for the map. Well, interesting. What is this unhappy with? Right now it's saying it encountered a curly brace where it didn't expect one. And then there's that curly brace which matches there. Just to make sure that it's not having issues with var being a keyword, which it shouldn't. Though things are a little confused here in my Eclipse, because while it's underlining stuff here, it says that drawable's fine. We'll come back to this. We'll fix the other errors. So our drawable has this method here, and we need to add that to each of our different drawable types. So what are we going to do with a rectangle? Well, we did play some with an XML format, drawing XML, where the top level was drawing, and then every drawable had a type associated with it, and then some data in there. So that's kind of what we need to do here. We need to say that we are going to have a drawable that has a type, and in this case our type is equal to rectangle, and then it stores off the values. Well, we don't have to store the drawing because we're loading this in as part of the drawing, but we need the x, the y, the width, the height, and the color. So x equals, and then we can say in curly braces, x dot to string, y equals y dot to string, width equals width dot to string, and height equals height dot to string. Okay, and then this has a color associated with it. Now the color is a little bit more complex, so I am going to make it a sub-attribute. And it's possible we'd have to write out multiple of these, in which case I could potentially isolate this code, but right now I'm not going to worry about that. So color with red equal to something, green equal to something, blue equal to something, and opacity equal to something. And then what goes into these somethings? Well, this would be color dot red dot to string, color dot green dot to string, color dot blue dot to string, and color dot opacity dot to string. And I hit save, and that seems to be happy. So I'm going to copy this whole method here, and let's take it and put it into the other things that we have. What about our draw maze? Meh. The way we have this right now, we actually don't pass anything into our maze. All of these values are set at the beginning. That's something that we could change, and ideally we would change these things so that these were passed in and therefore could be more easily varied. We could potentially save them, but in order to make this video go a bit faster, I'm going to just say this is type maze. It has nothing there, and it has no data inside of it, and that will create a drawable type for us for the maze. Our draw text, actually I should probably copy the stuff from rectangle for the text, because the text does have a number of these elements in there. Okay, So this will be, type is text. It has an X, it has a Y. It does not have a width or a height. So I'm going to get rid of those. It does have a color, but it also has a text type. Now the text though could be more complex, so I'm going to make that, it doesn't have to necessarily fit in a single line of code. They might have typed in multiple lines of code here. So I'm going to make that a sub-element so that it can properly hold that information even if it's more complex. And then up last is our transform. Our transform needs to store the type and the two values for it. Let's see, I'll probably copy the maze one because there's not really much overlap with the rectangle here. So this will be a transform, and this should say trans type equals, and then I'm going to take transform type dot toString. We'll have to play with that to figure out how we get it out of that. Value equal, or value 1 equals value 1 dot toString, and value 2 equals value 2 dot toString. Close and save. And it looks like our entire program compiles. So at this point we could try running it. And I can make a little drawing in here. We will add a rectangle, maybe add some text, turn our rectangle some other color so the text pops up. Okay, that's probably, actually let's change this to something a little bit different. And then I'm going to do a save. But instead of calling it drawing.bin or drawing.xml, I will call this drawing2.xml because I don't want to overwrite our previous one. I'll hit save. There were no exceptions. That's nice. And we can actually, we should be able to open this file. So inside of our workspace here, we have drawing2.xml, and under source we can see that we have this. Oh, but we didn't write out the children. So we'll come back in the next video. We'll make it so that our transform writes out the appropriate children, and then we'll also work on how we're going to load this back in. It's probably going to take a few videos to complete the XML, but this was the beginning. With the exception of the fact that transform doesn't save its children, we have it so each of our different drawable types has a toXML method and knows how to create XML for itself that we can then write out. We still have to work on doing the deserialization and taking XML and building objects from it as well.